What is the derivative x squared plus 10? Two x. What is the derivative of x squared minus 50? 2x. So here's my question. Then what function has a derivative equals to 2x? What function has a derivative equals to 2x? Well, what is it?
X squared plus a constant?
Yes. It's x squared. X squared is one of them, but it's not just x squared is not the only one. Could be x squared plus 10, x squared plus 50, x squared plus 9, x squared minus 50, minus 40. So we saw the answer to that is x squared plus some constant. That constant could be a positive number or a negative number. Well, that's what the antiderivative is. Can you tell me the function that has 2x for a derivative? And the answer is x squared plus a constant. Well, instead of writing all of this, the way we're going to ask the question, integration is called integral. We're going to put the integral, the big S here, 2x dx. What we're saying, what function that if you take the derivative with respect to x, when you took that derivative with respect to x, the answer was 2x. And we knew the answer is what? X squared plus c. Well, that's because I gave the derivative x squared. So if I come in and say, well, can you tell me what is the integral of x to the fifth dx? You might have to think about that. What's the answer to this? Go ahead, yeah. He said x to the 6. He was x to the 6.
Or no.
X to the 6 divided by 6.
Yep, it is actually x to the 6 over 6 plus some constant, or 1/6 x to the 6. Well, I don't want to guess on that, so how would I do that? Let me show you how we do it. Remember when we ask you what's the derivative x to the n, what was the rule? Remember what the rule was?
N minus
N times what? X to the power of what? N minus 1. We move the power to the front, we subtract 1 from the power. That's the derivative. That's not the integral. Well, here's the integral. The integral of x to the n dx. That's called indefinite integral. Doesn't have numbers on it. Notice on the bottom or the top there are no numbers here. The answer to that is we add 1 to the power. We do the reverse of that. We add 1 to the power and we divide by the new power. The only time this does not work, when what? What is the value of that when n equals -1? What is -1 plus 1? Can you divide by 0? So you can use that all the time except when n is a -1.
Is there a name for the integral sign?
Integral.
So,
Yep. That's called the integral. Or big S. Nobody calls it the big S, but integral.
yes.
Yep.
We'll go with that.
The integral of x to the n dx. Now, what about if n equals -1? Well, think about it. That means you have this. I bet you know the answer to that. What function has a derivative 1 over x?
ln.
Yep, it's the natural log. So when x is a -1, it is the natural log of the absolute value of x plus c. Why the absolute value? Because you can't take the log of a negative number or 0. So when x equals minus 1, the answer is the natural log of x plus c. So let's see how we're going to do these problems. Again, I'm trying to give you a quick review of Chapter 5, so for those people transferring somewhere else, when you see that big S there, that integral sign, you're not going to say, oh, what was that? So what is the integral, for example, of 4x squared dx? Just like the derivative, you can take that number, the 4, the constant, and move it to the front and put it in the front here. If you do that, this becomes 4 times the integral of what? X squared dx. Now, what function has a derivative x squared? Apply the rule. It says do what? Add 1 to the power. What is 2 plus 1? 3, and divide by the new power. What's the new power? 3, and don't forget to add c. So the answer to that is 4/3 x cubed plus c. That is the answer to the integral of 4x squared dx. When I gave you this question, I think Brandon yelled the answer, told us what the answer is. If you want to find, we did that early. And now you can do without guessing on it. Add 1 to the power. This becomes x to what? 6 divided by the new power, which is what? 6 plus c. What is the integral of dx over x to the 4th? Again, you can rewrite that as x to what power? Negative 4 dx. So let's add 1 to the power and divide by the new power. When you add 1 to the power, it becomes what? X to the negative 3 divided by what? Negative 3 plus the constant. You can clean it if you want to. I can put the minus on the top or on the bottom. I'll put on the front. Negative 1 over 3x cubed plus c. What is the integral of the square root of x dx? The square root of x can be written as x to what power? 1/2. So add 1 to the power and divide by the new power. So when you add 1 to the power, what's 1/2 plus 1? 3/2 divided by 3/2 plus c. Well, dividing by 3/2 is the same as multiplying by what? 2/3, yep. Yep. What is the integral of cosine x dx? That's why I said memorizing the trig. What function has a derivative cosine x? Who has derivative equal to cosine x? Yep, sine of x. And don't forget to add c. If this is indefinite integral, there's no numbers, you always want to add the constant. What's the integral of secant squared x dx? What function has a derivative equals to secant squared?
Tangent?
Tangent.
You're looking at me.
Tangent x plus c. What is the integral of negative cosecant cotangent x dx?
Cosecant.
Who has a derivative of negative cosecant cotangent?
Cosecant.
Cosecant x. So that the big S really tells you, or the integral tells you, what function has this for a derivative. Some people are saying, what happened to dx? Is what it says. When you took the derivative with respect to x, you came up with that answer. When I took the derivative, that was my answer. Just this piece with respect to x. So that's why it's the tangent x. What function has this for a derivative when I took it with respect to x? Is the cosecant x plus c. When you put the answer, the dx disappears, the integral sign disappears. If you have constants with them, if you have like 5, the integral of 5 cosine of x dx. The good news about the constant, we said you can pull them and put them in the front. So if you have a number like this, I can take it to the front and put it right there. And make that 5 times the integral of cosine x dx. And what function is derivative of cosine x? Here's the 5. Who has a derivative of cosine x? Try again. Sine of x, not negative. Sine of x. Do I need to say plus 5 times c or just c? C is a constant, so if you multiply it by 5, what's 5 times a constant? Still a constant. Who cares if it's c, big, small c, whatever, it's going to be a constant. What's the integral of dx? No. Remember, there's a 1. What function is derivative equal to 1?
X.
X. Don't forget to add the c. Okay, what about if you have this one? X to the 7th minus 5x to the 4th plus 3x. What function has this for a derivative? I can break it down just like the derivative. Go, let's break it down to each piece. Let me take the 5 in the front. I broke it down, the integral of this, the integral of this, the integral of that. And I took the constant, put them in the front. And apply that rule. Add 1 to the power and divide by the new power. This becomes what? X to the 8th over 8. There's the minus. There's the 5. What's the answer to x to the 4th? X to the 5th over what? 5. There's the 3. What is the integral of x? Add 1 to the power and plus the constant c. And you can clean that if you want to. This 5 will cancel that 5. You will have 1/8 x to the 8 minus x to the 5th plus 3/2 x squared plus c. I don't have a quotient rule just like the derivative. We don't have one here.
Can you break that apart into x plus 1 over 1 and 1 over x square root of x? And take the integral of both those?
That wouldn't make it easier either. You're on the right track, but I don't like what you did there. Because that's the multiplication.
Yeah.
You can't break the multiplication this times that.
Okay.
Could you break them into separate fractions?
Nope. You can't break them to the integral of the top over the integral of the bottom. It doesn't work. But you can take this, Brandon, and rewrite that You're saying, how's that going to help me? Well,
Bring it to the top.
I can make it x to the negative 1/2 times x plus 1.
Is that the only way
Yep.
to do that?
Yep. Now you're going to multiply these guys together, and what are you going to have? So I didn't integrate yet, but I'm just rewriting the problem. This becomes x to what power? 1/2 plus x to what power? Negative 1/2 dx. Now you can break it down to two separate integrals. Now that fits the format. The integral of x to the n. So what's the answer to the first one? Add 1 to the power. That'll be what? X to the 3/2 divide by 3/2. Well, dividing by 3/2 is the same as multiplying by 2/3. Add 1 to the power. This becomes x to what power? 1/2. Dividing by 1/2 is the same as multiplying by 2 over 1, which is 2, right? And don't forget to add the c. I'm squeezing it because I'm out of space here. So 2/3 x to the 3/2 plus 2x to the 1/2 plus c. Yes?
I just split them apart and I got the same thing.
Huh?
I split them apart and got the same.
What do you, I mean, split this over this and this over that?
Yeah.
Well, you end up with this one.
What do you mean?
You end up right there. Because what's x divided by the square root of x?
Alright.
X to 1/2, right?
Yeah.
And what's 1 over the square root of x? X to negative 1/2. So you can do that, divide this by this and this by that. It's the same as this.
Yeah.
But you can't break, when I said you can't split them, you can't take the integral of this over the integral of this.
Yeah.
That doesn't work. Yeah. There's a tricky one here. Sometimes we get a little bit like sneaky with them, like this one.
Sounds right up your alley, Zeus.
Yep. In a few minutes, we'll show you actually a different way of doing it. It's called use substitution. But right now, I don't have that. I'm trying to be creative here. Can I write this? 1 over cosine x times sine of x over cosine x. Can I do that?
Yeah. That would be tan over cosine.
Sine over cosine. I took one of the cosine, moved it to the front. And the reason I did that, what's 1 over cosine? That's on the board, one of the trig identities.
Secant?
That's secant of x. And what's sine over cosine? Tangent x dx. Now, okay, what trig function has this for a derivative? Has secant x tangent x for a derivative? Yep, secant x. Tangent would be secant squared. See, I just played with it, massaged it a little bit to make it look nice there, the way I like to see it. Like when you're at the pizza shop, you're playing with the stuff they were playing Play-Doh, bending, flexing, and making it look beautiful to fit the format that you like. I could even give you something like this. What is the derivative? It doesn't have to be x, it could be t. T squared plus secant squared t dt. I Again, you can break it down to the integral of t squared dt plus the integral of secant squared t dt. Integrate this. This is straightforward. Add 1 to the power, divide by the new power. So 2 to the third over 3. This doesn't fit that format. That's the trig, and that's why I kept telling you, you really want to memorize the derivatives. You can see right now, just a quick look at it, why you need to memorize them for. So for those people who did not memorize them, before you get to Calc 2, this summer make it really an effort to memorize them. I'm telling you, it will make Calculus 2 much, much, much easier. What function is secant squared for a derivative? Tangent. Don't forget to add the c. You always add c when you have indefinite integral. One more, since I have a space here for one more. E to the x plus secant x cotangent x minus 3 the 4th root of x dx. I can break it down the integral of e to the x dx, right? Plus the integral of secant x cotangent x dx minus, I can take the 3 outside the integral, the 4th root of x, x to what power? 1/4. Again, who has a derivative equal e to the x? E to the x. Who has a derivative secant? Cosecant. Otherwise we're in trouble here.
Yeah.
Cosecant cotangent. That's what it didn't work, because I made that up. Cosecant cotangent. So who has a derivative equals cosecant cotangent? Will be a negative, right? The derivative of cosecant is negative cosecant, so that would be negative cosecant of x. Here's the minus 3. Integrate that. That's x to the n. Add 1 to the power. 5/4 over 5/4, right? And dividing by 5/4 is the same as multiplying by 4 over 5. So you can actually make that e to the x minus cosecant x, and this will be minus 12 over 5 x to the 5 over 4 plus c. Always add that c.